Hey guys, this is Kisle from Edureka, and the topic for today's discussion is the Google Cloud Platform, popularly known as GCP. So without any further delay, let's go ahead and look at today's agenda. First of all, we'll be starting from the basic needs of cloud computing and understand what cloud computing is. Then we'll learn about the various cloud services and their providers. Moving ahead, we'll understand what is GCP and the reason behind choosing it. Next, we'll learn about the various services provided by GCP and the different regions and zones where it is present. And finally, we'll see how to create an account on GCP and learn how to create a project and work on it. So let's have a look at a traditional e-commerce scenario. Here we have a retail company which wanted to expand its business by starting home delivery, creating a website, and creating an app. The company was doing great while expanding its business, but then their website and app had an unexpected rise in traffic and things got a little bit out of hands for them. They faced some problems such as scalability issues, increasing the number of systems, increasing the number of staffs. They faced server problems. They needed systems that are fast and up 24/7. Moreover, they required additional security features for their customer visiting the sites and app. These requirements don't come in cheap, do they? Let's suppose that the company even bought 100 servers to handle the traffic, but later realized that at a time on an average, only 50% of the servers were used. The rest were sitting idle. Very frequently, the number reached 70 to 80%. That seemed like a waste of money and resources. So what do you guys think is the solution to these problems? If your guess was cloud computing, then you guessed it right. So cloud computing is exactly the perfect solution to these kind of problems. Let's see how. Cloud computing is basically getting the services you desire on your computer via cloud. It is the on-demand delivery of compute power, database storage, applications, and other resources that cloud service platform via internet with a pay-as-you-go pricing. It is the use of remote servers on the internet to store, manage, and process data rather than a local server or your personal computer. You don't need to buy thousands of servers or systems to work. Everything is managed by the cloud service provider. So cloud computing providers offer their services according to different models, of which the three standard models were NIST Infrastructure as a Service, Platform as a Service, and Software as a Service. So let's begin with Infrastructure as a Service. It refers to online service that provide high-level API use to dereference various low-level details of underlying network infrastructure, like physical computing, resources, location, data partitioning, scaling, etc. Infrastructure as a service is where the consumer can deploy and run arbitrary software, which can include operating system and applications. The consumer does not manage or control the underlying cloud infrastructure. Coming on to platform as a service. The capability provided to the consumer is to deploy onto the cloud infrastructure consumer created or acquired applications, created using programming languages, libraries, services, and tools supported by the provider. The consumer does not manage or control the underlying cloud infrastructure, including networks, servers, operating system, or storage, but has control over the deployed application and possibly configuration settings for the application hosting environment. Moving on to software as a service, the capability provided to the consumer is to use the provider's application running on a cloud infrastructure. The applications are accessible from various client devices through either a thin client interface such as web browser or a program interface. The consumer does not manage or control the underlying cloud infrastructure, including networks, servers, operating system, storage, or even individual application capabilities. Now there are various cloud providers in the market. Let's have a look at these providers. As you can see, we have DigitalOcean, VMware, Rackspace, Google Cloud Platform, Amazon Web Services, Microsoft Azure, Joynet, IBM Cloud, and Terramark. So there are so many cloud providers, then why go for Google? Google Cloud Platform is a suite of computing services that run on the same infrastructure that Google uses internally for its end user products, such as Google Search, Gmail, Google Photos, and YouTube. We all know how big is the database of Gmail, YouTube, and Google Search, and I don't think in the recent years Google server has ever gone down. It is the biggest in the world. So now let's have a look at some of the features of GCP, what really gives it an upper hand over other vendors. First of all, it is cost effective. There are no upfront costs required. Plus, you get discounts for consistent usage of resources. You pay per second, which is how a cloud should work. It is highly scalable. It can easily be scaled according to your needs with virtually no cost. Now, custom machine type is a feature of Google Compute Engine that lets you easily create a machine type customized to your needs. With custom machine types, you can create virtual machines with the optimal amount of CPU and memory for your workloads. Now coming to Internet of Things, GCP has an IoT-specific intelligent platform that unlocks business insights from your global device network. Google Cloud IoT is a set of fully managed and integrated services that allow you to easily and securely connect, manage, and ingest IoT data from globally dispersed devices at a large scale. You can even process and analyze and visualize the data in real time. Now coming to API platform and ecosystem. GCP's cross-cloud API platform enables businesses to unlock the value of data, deliver modern application and powerful ecosystems. Coming on to big data analytics, GCP provides fully managed data warehousing, batch and stream processing, data exploration with added Hadoop and Spark specific configuration and reliable messaging. Now comes one of the most important features of Google Cloud Platform, which is the Google Cloud AI. It provides modern machine learning services with pre-trained models and a service to generate your own tailored models. Their neural net-based machine learning service has better training performance and increased accuracy compared to other large-scale deep learning systems. Major Google Cloud applications include machine learning, photos, the app, the voice search, translate, and inbox, which is the smart reply. Now finally, GCP is serverless. This doesn't mean that there are no servers used by Google. So let's understand first what serverless means. Serverless is a new paradigm of computing that abstracts away the complexity associated with managing servers for mobile and API backends. There are no upfront provisioning. Just provide your code and data, and Google dynamically provisions your resources as needed. Applications with rapid time to market and unpredictable scale requirements benefit the most from it. So here we can see that Google has the highest growth rate and is increasing rapidly as compared to the other cloud providers. Now let's understand what is Google Cloud Platform and what are the various services provided by it. Google Cloud Platform is a suite of cloud computing services and management tools offered by Google. Alongside a set of management tools, it provides a series of modular cloud services including computing, data storage, data analytics, and machine learning. Now, moving forward to the services offered by GCP. Here are the major services offered. We'll discuss each one of these features in detail later in the video, but let's have a look at these services first. Firstly, we have compute, storage and database service, networking, big data service, we have certain developer tools, identity and security, we have the Internet of Things, we have the Cloud AI, which is Google's machine learning service, and finally, we have the management tools and the data transfer tools. So Google Cloud Platform services are available in locations across North America, South America, Europe, Asia, and Australia. These locations are divided into regions and zones. You can choose where to locate your application to meet your latency, availability, and durability requirements. Regions are independent geographic areas that consist of zones. Locations within regions tend to have a round-trip network latency of under just 5 milliseconds. So let's have a look at the various locations where these servers are located and the number of zones for that particular region. Here you can see that there are a total of 15 regions with at least 3 zones in every region. A few cloud platform services are managed by Google to be redundant and distributed within and across regions. These are mainly the global resources or the multi-regional resources. Now, regional resources are resources that are redundantly deployed across all the zones within a region. For example, App Engine application. This gives them higher availability relative to zonal resources. Zonal resources operate within a single zone. If a zone becomes unavailable, all the zonal resources in that zone are unavailable till the service is restored. Now let's go ahead and see how we can create an account on GCP. First of all, you need to go to cloud.google.com. Here you have the option to try it for free. All you need to do is sign in with your Google account. You need to accept the terms and conditions of Google. And after that, you have access to all the cloud platform products with a $300 credit, which can be used across for a span of 12 months. There are no auto recharge after the trial ends. And after that, you agree the terms and conditions, you will be directed to this page. Now just go to console. Here you will find a dashboard which includes all the summary of the various Google platform services that you are using. As you can see, on the left hand side we have the project info, resources, traits, we have the APIs requests. On the right hand side we have the platform status, billing, and error reporting. And at the bottom we have the news and documentation which can also be used. So let's go ahead and look at the various services offered by Google in detail. Starting with compute, GCP provides a scalable range of computing options you can tailor to match your needs. It provides highly customizable virtual machines and the option to deploy your code directly or via containers. Google Cloud Compute Engine delivers virtual machines running on Google's innovative data center and worldwide fiber network. Google App Engine is a platform for building scalable web application and mobile IoT backends. App Engine provides you with built-in services and APIs such as NoSQL database, Memcache, and a user authentication API. App Engine will scale your application automatically in response to the amount of traffic it receives. So you only pay for the resources you use. Just upload your code and Google will manage your app's availability. Now, Google's Kubernetes engine is a powerful cluster manager. Kubernetes engine schedules your containers into clusters, keep them healthy, and manages them automatically based on the requirements you define. It is based on Kubernetes, the leading open source container system, giving you the flexibility to take the advantage of on-premise, hybrid, or public cloud infrastructure. Coming on to Google Cloud Container Registry, it's a private Docker repository that works with popular continuous delivery system. It runs on cloud platform to provide consistent uptime on an infrastructure protected by Google security. You pay only for the storage and internet you use, nothing else. Finally, coming to the Google function, Google Computing has made possible fully serverless models of computing where logic can be spun up on demand in response to events originating from anywhere. With Google Functions, you can construct applications from bite-sized business logic built to nearest 100 milliseconds only while your code is running. Now coming on to the networking services. With Virtual Private Cloud VPC network, you can provision your Google platform resources, connect them to each other using Google-owned global network, and isolate them from one another. You can also define fine-grained networking policies with cloud platform on-premise or other public cloud infrastructure. You can scale your application on Google Compute Engine with the Google Cloud Load Balancing. Distribute to load balance compute resources in single or multiple regions, close to your users and to meet high availability requirements. Cloud load balancing can put your resources behind a single IP and scale your resources up and down with intelligent auto-scaling. Coming on to the Content Delivery Network, also known as CDN, Google Cloud CDN leverages Google's globally distributed edge caches to accelerate content delivery for websites and applications served out of Google Compute Engine. Cloud CDN lowers network latencies, offload origins, and reduces servicing costs. Google Cloud Interconnect allows Google Cloud Platform customers to connect Google via enterprise-grade connections with higher availability or lower latency than their existing internet connections. Now coming on to Google Cloud DNS, it is a scalable, reliable, and management authoritative domain naming system service running on the same infrastructure as Google. It has low latency, high availability, and is a cost-effective way to make your application and services available to your users. Cloud DNS is programmable. You can easily publish and manage millions of DNS zones and records using this simple user interface, command line interface, or API. Now moving forward to storage and databases. Google Cloud Storage redefines what the industries can expect from online storage by providing an undefined offering across the availability spectrum, from live data tapped by today's most demanding application to cloud archival solution. Now, Cloud SQL is a fully managed database service that makes it easy to set up, maintain, manage, and administer your relational MySQL or PostgreSQL databases in the cloud. Cloud SQL offers high performance, scalability, and convenience. Hosted on Google Cloud Platform, Cloud SQL provides a database infrastructure for application running everywhere. Cloud Bigtable provides a massive, scalable NoSQL database suitable for low latency and high throughput workload. It integrates easily with popular big data tools like Hadoop and Spark, and it supports the open source industry standard Edge-based API. Cloud Bigtable is a great choice for both operational and analytical applications. It can be used for user analytics and financial data analytics as well. The Google Cloud Data Stores give you an elastic, high available, document-oriented database as a service. It is fully managed, so you do not need to deploy, update, configure, or manage your database solution. Persistent disk is a high-performance block storage suitable for virtual machine and container storage. It offers unmatched price-to-performance ratio. You only pay for the capacity and you are never charged for provisioning IOPS. Now with Google Cloud Platform, you can focus on finding insights rather than managing your infrastructure, and you can combine cloud-native services with open source tools as needed both in batch and stream mode. Here is where big data comes into picture. Google BigQuery is Google's fully managed low-cost analytics data warehouse. BigQuery is serverless. There is no infrastructure to manage, no need to guess the needed capacity or over-provision. And you do not need a database administrator. You can focus on analyzing data to find meaningful insight. Google Cloud Data Proc, a managed Spark and Hadoop service, is used to easily process big data sets using the powerful and open tools in Apache Big Data ecosystem. Control your costs by creating managed clusters of any size in about a minute and turning them off whenever you are done. Now, Google Cloud Data Lab is an interactive notebook based on Jupyter to explore, collaborate, analyze, and visualize data. It is integrated with BigQuery and Google Cloud Machine Learning to give you easy access to key data processing services. Now, Google's Cloud PubSub is a serverless, large-scale, reliable, real-time messaging service that allows you to send and receive messages between independent applications. You can leverage the flexibility to decouple systems and components hosted on cloud platform or elsewhere on the internet. Now, coming to machine learning, Google Cloud AutoML is a suite of machine learning products that enables developers with limited machine learning expertise to train high-quality models by leveraging Google's state-of-the-art transfer learning and neural architecture search technology. Google Cloud TPUs are a family of hardware accelerators that Google designed and optimized specifically to speed up and scale up machine learning workloads for training and inference programmed with TensorFlow. Google Cloud Machine Learning Engine makes it easy for you to build sophisticated large-scale machine learning models that cover a broad set of scenarios from building sophisticated regression models to image classification. It is portable, fully managed, and integrated with other Google Cloud data platforms. It also offers powerful video and image analysis along with the best speech and text recognition. Coming on to identity and security, Google Cloud Identity and Access Management, which is the IAM, lets administrators authorize who can take action on specific resources, giving you full control and visibility to manage cloud resources centrally. For established enterprises with complex organizational structures, hundreds of workgroups, and potentially many more projects, the Cloud IAM provides a unified view into security policy across your entire organization, with built-in auditing to ease compliance processes. Now coming on to monitoring tools, Stackdrivers delivers real-time monitoring and logging across GCP, plus useful diagnostic tools. Manage your apps on GCP with the web-based console, mobile app, or Cloud Shell. Finally, coming to the developer tools. Google Cloud Platform provides a collection of tools and libraries that help you develop quicker. Google Cloud SDK is a set of libraries and tools that you can use to manage computing resources and applications hosted on Google Cloud Platform. With the Cloud SDK, you have interactive command line tools to manage your virtual machines, your Class SQL instances, and your deployments. So let's go ahead and look at the various resources and the services provided by Google. Here you can see on the left-hand side, you have a tab on which you have the compute services, the storage services, the networking services, Stackdriver, and the various developer and management tools. Here you have the big data tools, you have the IoT services, and also various other services. So first of all, let's go ahead and create a VM instance. This can be done in the compute part. Just go to the compute engine, click on the VM instances, click on create. As you can see here, you can provide the name for your instance, select the zone your instance should be present according to your needs. You can also select the machine type, and every other machine type has a different billing amount. Here I'm going to select the small one. You can also select the boot disk image, what will be the base OS of the VM you are going to create. Here I'm selecting CentOS, and then you just need to tap on this create button, and within minutes, I should say within seconds, your instance will be created. As you can see, the instance was created within seconds. Now let's go ahead and fire up this instance. It's a virtual machine having the base image of CentOS 7. So let's first update the system. As you can see here, we have the virtual keyboard, or we have the settings. We can change the color themes, the text size, the font. We can upload or download a file very easily. Now CentOS 7 comes with a pre-installed Java 8. Let's go ahead and check if that's the case here. There's no Java, so let's install it. So within seconds, I have Java installed in my system. Similarly, you can install any of the frameworks you want to install VM, as you do in a similar manner in your local machine. Now that we have created an instance, let's go ahead and create a cluster. In the Big Data section under Data Proc, you have the cluster option. These clusters are mainly used for Hadoop and Spark purposes of the Apache framework. In the similar manner, you can input the name of the cluster, select the region where it should belong, and the zone. You have the cluster mode, which is single node, one master, zero workers. Standard, you can easily deploy one master and n number of workers, and highly available, which have three masters and n number of workers. So this is the master machine, which is one CPU and 3.75 GB memory. I don't need this much of space, 100 GB is fine. Now for the replication factor, which is defined here, is 2, which is minimum 2. You can also set the disk image size of the replicas. Let's go ahead and change this. Now just tap on create, and within minutes, you will have your cluster up and running. So while the cluster is being created, let's go ahead and check out the dashboard. Here you can see in the left hand side, in the compute engine section, I have 5 instances, of which one is the VM instance which I created just now, and the remaining 4 are the cluster instances. 1 is the master and 3 are the worker nodes. You have the billing estimate on the right hand side, the APIs, the CPU usage. Let's go ahead and check if our cluster is created or not. Yeah, you can see the cluster is created. And suppose I want to submit any type of job, you just need to go to the jobs, submit a job. Select your cluster. You can select the job type, which is Hadoop, Spark, Hive, PySpark, Spark SQL, or Pig. You can enter the main class or the jar, the arguments you want to pass, or the jar files needed to submit a job, and just you need to click on the submit button and the job will start running. We'll learn more about these features and services in the upcoming videos. Thank you for being with me for such a long time. Thank you.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!